The semiconductor industry, brought forth by Sir Michael Faraday. What is a semiconductor? The ideology had come to light when Michael Faraday noticed electricity was created as temperature was increased in silver sulfide. Made of specialized silicon crystals, a semiconductor produces energy by adding or removing electrons based on chemical reaction. Chemical reactions will cause for more or less movement, though the goal is to maximize the energy produced. On the right is an enlarged semiconductor, as most are microscopic. The rectangular pieces would be electrons, and each sphere would represent a chemical compound. Technological advancement in the semiconductor industry. Several millions are spent each year in research and development to further create new efficient and more productive devices. These devices are also known as tools or photomask tools. The photomask tool will etch the grooves into the silicone or glass plates. Etching is performed using either UV light or lasers. Constant replacement, as newer upgraded models are constantly being produced. Large revenues are invested in the research development. Cost is several millions of dollars for one of these devices. It's approximately 14 million. New tools are implemented every 6 months to a year. A facility may utilize several tools simultaneously, and facilities across seas will inherit the older tools and manufacture older plates, exporting them around the world. Economic collapse. In 1994, the semiconductor industry, as well as many others, took a dive. This followed the recession of 1991 as the bond market faced a dramatic sell-off. This sell-off followed an interest increase in treasury rates by 1.55%, bringing the rate to 7.75%. In 2013, treasury interest rates were at 5.8%, and to further provide perspective, today the current interest rate is at 3.18% and is on a steady course upward. What were to happen if the semiconductor industry were to fail today? On the right is a Fred graph for the 30-year Treasury constant maturity rate. This shows fluctuations in the Treasury interest rate. Production, productivity, and new technology. Using photomasks greatly improve the efficiency and production capabilities. Each tool eliminates the need for human intervention, though individuals observe and make changes to information relayed as needed. The tool is sensitive to humidity, temperature, air contaminants, and impurities in the water. Tools are from manufacturers across seas to include Japan and China. Assembly and maintenance is required by manufacturer-certified engineers. Local contractors can be trained, though their training is limited to the basic maintenance and repair procedures. Each tool must never lose power, or it can take up to 6 months to continue operation. Various chemicals, power supplies, water filtration systems, and air filtration systems are all active at all times. The fab, as mentioned in the video, must remain positively charged with air to prevent contaminants from entering the work area. The temperature must never drop below approximately 70 degrees, and humidity must never alter within 0.01%. The quantity of plates produced is fully capable of doing what several lab technicians could do in the same hour. This does not include the determinant that humans are more prone to error. The technology utilized is capable of operating 24 hours a day, 7 days a week. The cost relayed to the customers or consumers are directly affected by the lower operational costs, though, as mentioned earlier, a large quantity of the profit or revenue is returned into the market for further research and development. Canon has announced that it will begin mass producing copies of these photomasks. They're not going to be manufacturing their own photomask, though they will copy the ones provided by major companies like Micron or Photronics. This allows costs to be further reduced for the consumer, allowing for further consumption. Referring back to the earlier question of what would happen without semiconductors. If semiconductors replace the tube in old televisions and Mac computers, one would only be able to revert back to the past and bring back the tube. That would increase size of TVs, that would increase size of telephones, and that would reduce the need for satellites. Today, the semiconductors manufactured are utilized for several applications such as national defense, smartphones, smart TVs, and self-driving vehicles. Without these semiconductors, the way of life would result back to tube televisions and the analog telephonic system. As I mentioned, the need for satellite would become obsolete. The graph in Figure 2 displays a dramatic decrease during the bond sell-off in 1994. The industry seemed as if it were on the edge of collapse. Maybe so, though without the industry, the simplicities of life today would be prolonged. Sales have increased regarding communication electronics, computers, and semiconductors in the recent years. Perhaps there's a correlation. Figure 3 can show this steep correlation and the demand increase for these such goods.